Welcome everybody to another Stealthness coding session. Today I'm going to show you how to use JUnit4 from the command line without using an IDE. Now we're using JUnit4 because it's a little bit easier to compile from the command line than the current new version of JUnit5, but if you're using an IDE then you'd probably migrate to JUnit5, but there's majority of JUnit5 and 4 are very similar. Just JUnit5 does have newer abilities that JUnit4 doesn't. So without further ado, I'm going to just show you the current directory we have. Here we have our current directory. I've got two simple classes that I've got in my source files, bank account and bank account implementation. I'll go through them in a moment. And I have a very simple test account that I'm going to be using to test them with. Now I've already downloaded JUnit4. You can actually get it if you do a Google search. Just click onto this link and then that will lead you to another download, and that will allow you to download. Now I've already downloaded them and placed them into this location. Now I'm going to be using the slightly older versions. The current versions that you can download are 4.13 beta JUnit4 and Handquest 2.1, but because I have a slight compatibility issue, I'm going to be using the slightly older versions of Handquest Core 1.3 and JUnit 4.12. So let's have a look at our test bank account class, and it's very simple. It imports two things at the moment. It imports our test annotation, and it also imports a fail method. What we're basically going to do is we're going to compile this class and we're going to run it, and of course, being the fact that it only has this one method which says test fail and it uses the method fail, is going to fail the test. So without further ado, we're going to compile this class. So we use our javac compile command, and we're going to set the destination to our out and our test location. To compile, we just need the JUnit jar. When we actually run the test, we'll use both JUnit and the Handquest, but just to compile, we just need JUnit. So we add that to our class path. We use -cp to add to the class path, and then we add the class where it's located, which in this case is in our libraries folder under JUnit, and we're going to then use 4.12.jar. And remember, when we add jars, we actually add the full path of the .jar, not just the location of where they're located. Then we add the actual file we wish to actually compile. In this case, it's test simple test bank account.java. Okay, and if I do tree now, we'll see that the compile class has now been compiled there, and we're now ready to run. So as I said before, when we actually run it from the command line, when we're actually gonna run this test, we're actually gonna need to add the class path of the location of where it's currently is. So in this case, it's in the out test, and then we need to add the location of our two jars. So that's home, Stealthness, WS, libraries, JUnit, and then Handquest, and it's going to be 1.3 that I'm going to add, and then I'm going to add the next one. So again, it's /home, /Stealthness, /WS, /libraries, /JUnit, /JUnit 1.2. So we add the three locations: the location of where the class is actually compiled, the locations of our two jars, and then from there we're actually going to run a specific program, and that's located in JUnit runner and it's called JUnit.core, and any arguments that it takes afterwards will be the classes that it will attempt to test. So in this case, we are going to test simple test bank account. Okay, and as we can see, as pretty much expected, since we only had that one method fail, we can see that it actually did fail. It says there was one failure. Okay, and it even tells us the location of that failure, which was at in test bank account at Java line 9. So if we go to our thing, we see at line 9, well, it failed because it pretty much said fail. So what I'm going to now add is I'm going to add actually a test that passed, just to show you that it don't, what it looks like when it does actually pass a test. So for this guy, I'm going to create a new test one. I'm going to annotate it with test. And I'm going to call it test void test true. And this time I'm going to use an assert true. Assert true, and I'm going to make it true, so it should pass this test. I'm also going to have to add to this now. I'm going to have to import that method, add it org .JUnit .assert true. Right, so now we save that up, and now we're going to rerun our recompile and recode. So recompiling the test code, and then rerunning the test, and we see that we have 2 tests and we still have 1 failure, but we do have actually now a passing test. So let's suppose that we no longer actually need this failing test, so I'm going to use another annotation here called add ignore. Test not needed. And I'm going to have to add that. Saving it up, recompiling, rerunning, and there we have a complete all our tests passed because it's now actually ignored that test, so it's only running the only one test that's there, and that test says true, and that's what we get. So we've actually completed. So now I'm going to move on to our actual classes that we're going to test. So here I've got a simple bank account interface which has 4 methods: withdraw, deposit, update, and get balance. And remembering that when an interface only contains method, it doesn't have any implementation. This is the way that Java achieves polymorphism. So we set up our interface and then we're going to have an implementation of that. And in this case, it's going to be a very simple implementation. So it's going to be called bank account implementation, and here I've got a very bare basic bones implementation. I've got a single field that represents the current balance. It's all default set to 0, and I've also got a method, and because the method requires a return value, I put in a return value of -1.0, so that I know that's a should be a general figure that should have no meaning so whatsoever, but it will allow us to at least compile the code so that I can then at least test it. So it's very bare bones. So first I'm going to compile those classes. So again I'm going to use the Java compile command. I'm going to set the destination to our out and deduction. And then I'm going to select our classes that we wish to test. In this case, they're in source. And this time I'm going to compile all of them that are of type Java. In this case, the reason that didn't work is because actually they're located in simple star.jar. Oh, .java. Very silly of me. And there we go. And now we can see that I've compiled my two classes, so they have been compiled. So now I actually also now need to write a test. In general, in test-driven development, we should always write the test before we actually write the code for the test. So here I'm going to test. So I'm going to delete the tests that I don't actually need. I don't actually need these tests anymore. I don't need the ignore, and I don't need fail or true, but I'm going to just alter this one to assert equals assert equals. So here I'm going to write my first test, so it's going to be at test, and then I'm going to do public void. I'm going to test new bank account is or has 0 balance, and that's a reasonable thing to test. So if we create a bank account, we should reasonably expect that it's got to have 0 balance when we set it up, because I haven't got a constructor, I haven't specified how it is, so that's a pretty reasonable assumption. There we go. So assert equals, and so we put our expected amount, which is 0.0, and then we put our actual amount. And so in this case, we got to create a new bank account, which I haven't actually done as yet. Now, so for that, we're going to do a new bank account. So we set it as the interface new bank account, but we're going to set it as a actual new bank account implementation. Now, since they're in the same package simple, I shouldn't need to add them. So from here, I got BA, and then we get balance. So we save that up. So we now need to recompile our test case. So if I go back along my commands, I then double check that that's the method. Yep, for the simple. So we recompile that. That's because I added new in the wrong place there. Save that up. Now in this case, the reason why it can't find new bank account is because it actually doesn't know the location, because I haven't actually added it to the class path. So now I need to add the location of the class path. So in this case, it's on out/production, and then there. So when I now run that, now it comes up with another thing, which is about a depreciation API. Now, if I want to find out some more information about this, I can actually run that with the command. So in this case, I'm going to run the command excellent, and that's going to tell me some more information about the reason. So the reason it came up with the command is because it's actually depreciation of this equals. And the reason being of this is because this is actually a very bad way to compare to the doubles, because doubles can range for a thing and can be the thing. What we need is we need a tolerance. So here I'm going to add in, because there's actually in the method, there's a method that actually specifies a tolerance. So I'm going to add that in as a constant. Private static final tolerance. Again, this allows me that if I want to change this tolerance later in, depending on the standard of the code, so I'm going to just set a very reasonable tolerance there of 0.01. So I'm going to save that up. So I'm going to use the previous one to compile this, because I don't need to find out. I found out what's wrong, and because I forgot to specify it as a double. Okay, so now having that, I can now then run that command. So here I now run it. I double check that I've added everything. I've got test thing. But because it also uses a bank account, I also need to also add to the class path. It couldn't find the bank account, and that's because it's not actually on the class path. So we shall add that. And there we go. We now have that running. And in this case, we now have a failure. And the reason we have a failure is because when it returns, it expected 0.0, but when it returns it was -0.1. So let's have a look at our bank account implementation, and here we can see that it returns just 0.1. What we really want it to do is return the actual common balance. So let's change that code. So we return this .current balance. We save everything up. So we need to recompile, of course, our bank account classes. So we will do that there. And we shall now rerun the tests on test bank account, and now we actually have a pass test. So that's the first one. So what we've tested is that if we create a bank account, so let's make another test, and this time let's test that if we actually add some money to the case. So test void test adding 100 adding X amount to bank account. Now, again, if I would have to create another bank account object so that I could test against. Now, if I'm going to have lots of tests, I'm going to probably need a bank account object quite a few times. So what I'm going to actually have to do is I'm going to use another annotation. I'm going to actually set up a bank account before, and here I'm going to use the annotation of before. Public void, and by convention we usually call this method setup, although it doesn't necessarily need to be called setup, as long as it has the tag app before it will be run before each test. So here I'm going to actually move this piece of code to here. But I'm actually also remembering that I need to have that available for all. So here I'm going to declare it. So I'm going to declare a new bank account, and then I'm actually going to substantiate it in the setup, and then whenever I run a test I will be able to call upon it. So on here I'm going to then deposit. I will now check what the actual thing, and it's called deposit, and it takes in an amount. So I'm going to deposit 100, and then I'm going to run the our test. So in this case, because I'm adding 100, I expect to actually get 100. So let's save everything. So again, we always create the test before we actually change the code. So I'm going to recompile the actual test code. Oh, a little mistake there. Well, one thing I have also forgot to I'm going to actually add import org.JUnit4, otherwise it won't understand the annotation. And then let's run that test. So we run 2 tests, but we have a failure. And the reason we have a failure is because when we actually run the test, we were expecting 100, but we got 0. So let's go to our bank account implementation and see what's going on. Well, of course, when we actually run deposit, it doesn't actually do anything to the current account. So obviously, we want to change the amount. So we wanted to add this current balance. Equal to, I could also do this current balance plus the amount. So that's one way, it makes it very clear, but I'm also going to now use the common shorthand notation of equals plus, which means add this amount to the current amount, which is a nice handy shortcut to remember. So we're going to save that. So of course we compile all our code again. We compile our tests. And then let's run our tests. And there we see that we have our 2 tests that have passed. So, and then of course we could go on and test other methods. So we could test the withdraw method, so we could test that if we have an amount that we withdraw amount, and we can test that, and we can then work this class up and thing. So I hope that gives some nice demonstration of how you can run the JUnit4 from the command line. Comments are welcome below. Anything constructive criticism, feel free to add. I will try and answer any questions anybody ever wants. And thank you for watching and listening. And good night.